thanks to all you guys for spending your lunch hour with me, especially on like the most beautiful Friday we've had in a really long time. I mean, there is free pizza afterwards, so I hope it'll be worth it. And today I'm really excited to talk to you about the work that is near and dear to my heart on human health at the intersection of these two different disciplines, you know, the environment and humanitarian crises. My work as an environmental epidemiologist is primarily to understand how the health of the environment influences the health of humans. And the way that I like to do that is by applying principles of epidemiology and principles of public health in general to international low-income contexts, particularly those that are impacted by complex humanitarian crises. So today I just want to kind of give you a brief outline of the problems, why I'm interested in this topic, and why I'm hoping to get you guys interested in this topic too. I'm going to start by just going over some trends in displacement, and then I'll talk about increasing climate change issues in the context of this displacement, and then give you an overview of the issue and the nexus dynamics that are involved in it. And then I'm going to close today by telling you a little bit about my current research project, and then hopefully a really fruitful and engaging discussion with you guys. So to give you just an overview of global trends in displacement, and by displacement, I mean people who are removed from their homes, either forcibly or they have no other choice other than to leave their homes. And just before this talk, I tried to like smoosh this graph. It didn't work very well. And the reason I wanted to smoosh it is because you can see that over the past decade, from 2010 to 2020 or 2019, you can see certain trends are increasing, but I don't feel like this graph really does it justice in that, for example, when we look at the light blue graph, it's actually more than doubled from 15 million to over 40 million in the past 10 years. And I feel like it should be like way more extreme on this graph, you know? So what we're looking at here are, like I said, the global trends in displacement. And this graph breaks it down by types of people who are displaced. So refugees, asylum seekers, IDPs who are internally displaced people, and then stateless people. And the reason why these distinctions are important is because these people are entitled to different types of rights and different types of protections under international humanitarian law. So for example, a refugee, like we often hear about refugees in the news, those are people who actually cross an international border, and it's for a very specific reason, for persecution, basically. But then we also have asylum seekers and then IDPs, internally displaced people. And the internally displaced people are the light blue color that's increasing really dramatically. Those are people who are displaced from their homes, but they don't actually cross an international border. And the reason that that's important is because without crossing an international border, they're not entitled to any specific kinds of protections under international humanitarian law. And the reason why they're actually displaced from their homes to begin with is often because of their own host governments, right? Their own environment in which they live, which is causing them to have to leave their homes for whatever reason, but then they're not able to get any protections once they leave their homes. So this is the group that I am particularly interested in. Displacement happens for a lot of different reasons, but there's two main categories that we can think about displacement in terms of: conflict and also disasters. So we can see over time, we see a pretty good mix in terms of conflict-related displacement and also disaster-related displacement. But disaster-related displacement is increasing over time, and it's accounting for a huge proportion of the actual numbers who are displaced from their homes. Starting with the easy one, conflict-related displacement, conflict-related disasters. I say it's easy because it's easy to conceptualize. That's war. People are displaced from their homes. They are subjected to humanitarian terrors when they experience war and conflict. This is a cool chart that I like to use because number one, I'm a visual learner. And number two, I think that it does a really good job of actually displaying the trends in conflict over time. If you just like take a stand back and look at just the shapes and the colors. The light blue represents low intensity conflict. The dark blue represents medium intensity conflict. And then the red represents high intensity conflict. And if you're just looking at the shapes here, the distribution of the conflicts between 2006 and 2016 has remained relatively stable. But if you look at the number in the middle, which represents the absolute number of conflicts over this decade, we see that conflicts are increasing pretty significantly over time. I'm a public health person. We care about this because of obviously the direct conflict related deaths and morbidity and mortality, but we also care about this because of the secondary displacements and the secondary morbidity and mortality that are happening. This chart this graphic from the New York Times is kind of old, but I think that it does a really good job of depicting the nonviolent deaths and the nonviolent morbidity and mortality that are happening related to conflict. This particular example is in the Congo, which has been the recipient of high intensity conflict for decades now. And you can see here that for every one violent death, so every one combat related death, we're seeing 62 nonviolent deaths. And these are like by and large preventable deaths, right? We're seeing things like malnutrition, respiratory disease, fever, deaths from childbirth. And overall, the vast majority of people who are being impacted are young kids, right? So these aren't people who are involved directly in the conflict. And then the second type of disaster that we think about when we're talking about humanitarian responses are natural disasters. So these are things like earthquakes, cyclones, heavy rain events, drought, fires, you name it. These ones are like easy to conceptualize in theory, but they're kind of hard to pin down. But I want to kind of go back on that a little bit, because when we think about natural disasters, we actually have to think about the fact that they're not natural. Natural disasters do not exist, right? So when we think about natural disasters and we use that term, we actually have to be careful. And it's something that I'm learning every day to try and increase my vocabulary to start referring to them as natural hazard related disasters. And the reason is because disasters themselves are the product of hazard times vulnerability times exposure. So natural hazards exist all the time. We have heavy rainfall events, we have earthquakes, we have monsoons, fires, and so on. But they only become a problem when that hazard meets vulnerability, when that hazard meets exposure. So if there's not a group of people who are living in this area who are vulnerable, who are exposed, then we're not going to have a natural hazard related disaster. But increasingly, we're seeing as population grows, as we become increasingly urban, as conflict is rising, as natural disasters are rising, we're seeing a huge rise in these natural hazard related disasters and disaster risk. So like I said, this is kind of like new terminology. So these graphics are from MDAT, which is the Emergency Management Database, which is really closely related to the UN, and they're still using the term natural disasters. So it's shifting, we're trying to work towards it. But as you can see in this graph, over the past 100 years, we're seeing a huge increase in the number of natural hazard related disasters across the world. Again, not a huge issue in and of itself until these natural hazard related disasters meet with some sort of vulnerability or exposure. If we just zoom in on the past 50 years, we can see this trend line is increasing at a pretty concerning rate. And it's actually projected to increase by 40% by 2030, which is quite a substantial increase. In terms of like the proportion of natural hazard related disasters that are happening and their attributable causes, we're seeing overall the vast majority are due to an increase in floods. And this is undoubtedly related to climate change. So again, not a huge issue in and of itself until these disasters are met with some sort of exposure or vulnerability. So when we think about the actual number of people who are impacted by these disasters, we see that that's increasing pretty steadily as well. So what does this all mean? We have these conflict-related disasters, we have these natural hazard-related disasters. At the end of the day, over 44,000 people are newly displaced from their homes every single day. That's the entire population of Burlington displaced from their home every day. And the reason why we care about this, besides like obviously the obvious reasons, are that once you're impacted by a disaster, your mortality increases significantly. So this is going back to that graph about the non-violent related deaths in the Congo, for example. So once you're displaced from your home, your risk of morbidity and mortality skyrockets. This is also concerning because refugee crises aren't just like one-off things where people are displaced from their homes and then they're able to go back. On average, refugee crises last for approximately 26 years. So these can be entire generations of people who are born in refugee camps and end up staying there for their entire lives. So disasters happen and people are moving a lot. And this graph is cool because, like I said, I'm a visual learner, but it also demonstrates where people are coming from and where people are going to. And if you look at just where people are coming from, you can see that they're coming from pretty natural hazard related areas that are impacted heavily by natural hazard related disasters and also conflict related disasters, but then they're going to those same kinds of places, right? So they're not like going to places that are offering them protections from either natural or conflict related disasters. So as a result, we're seeing refugee camps spreading up all over the place. And we're seeing refugee camps in rural areas, but also in cities. And we're seeing that they're going from being these temporary settlements to these long protracted settlements. Like I said, the average is 26 years. And then they're going from small to medium to actual cities with like functioning city infrastructure. This is a picture here of Zatari camp, which is one of the world's largest refugee camps in Jordan. And I wanted to include, I probably should have, this cool YouTube video that shows a time lapse of the growth of Zatari. It's just totally striking how quickly it grows. So from a public health perspective, this is obviously a really concerning issue, right? When a population or an individual is impacted by a disaster in a humanitarian response, we see a damage and a breakdown of infrastructure. We see high levels of food insecurity, crowding, water and sanitation issues. You have to think about where people are getting their water from. You have to think about where people are going to the bathroom. And obviously these people are under a huge amount of stress, which, as you know, can lead to a number of adverse health outcomes. We see disabilities related to injury. So people are fleeing conflict or they're fleeing natural disasters and they're at high risk of injury. And then of course, violence and diseases are really, really common in these populations. So when we try and actually do something about this, there's a lot of challenges. There's of course challenges to language and culture, and there's challenges in the fact that there's mass displacement happening and it's hard to track where people are going. There's also the challenge of conflict and of poor accessibility, of resources and of coordination. I took this picture when I was in South Sudan, and it is such a volatile situation that you're not actually allowed to take pictures like anywhere. So I'm taking this picture driving down the road, like with my camera kind of tucked in, not being able to be seen by anyone. And if I had to do it over again, I probably would not have done that because it's probably pretty dangerous. But it just goes to show of the difficulties of operating in a humanitarian context. So this all leads me to what I'm interested in, which is this nexus of health, the environment, and conflict. We have so many different types of displacement, right? Like I feel like I've kind of reiterated that enough. We have these disaster-induced displacements, but then we also have the displacements that are provoked by climate change. But then we also have this unique type of displacement that actually happens within the refugee camps themselves, where people are moving within the refugee camps, where people's homes get destroyed because of climate risks like fires, landslides, or floods, and they have to actually move locations within the camps itself. And so all of this interest of mine led to my current research project, which is funded by the Global Infectious Disease Corps over in Larner College of Medicine. And it's called Understanding the Impacts of Environmental Factors on Diarrheal Disease in the World's Largest Refugee Camp, which is in Cox's Bazar, Bangladesh. This is an aerial photo of Cox's Bazar. Interestingly, if you just like Google Cox's Bazar, it's actually a resort town. So it's this beautiful beach town that is, I mean, yeah, it looks like beautiful, but then when you zoom out, you're seeing these huge, densely populated, massive, expansive refugee camps. And just the juxtaposition of it is really drawing. So this project is a highly collaborative effort. Pablo Bose and Brendan Fisher are collaborators on this project, and they are affiliated with the GUND as well. And then I recently roped in Jillian to help with the forest cover analyses part of it. And then we have these two amazing research assistants who have been working on pulling data that, as you'll see, can get a little bit complicated and tedious as we go along. So they've done an amazing job. So just to give you a background on the situation, Cox's Bazar is the fastest and largest growing refugee camp in the world. The crisis itself unfolded in 2017. The people living in Cox's Bazar, Bangladesh, are generally from Myanmar, previously known as Burma, and they're Rohingya refugees. And the reason why that's important is because the government of Myanmar basically said, anyone who's Rohingya, you are not a Myanmar national, we do not claim you, and therefore they become stateless people. And again, that's important because they're not entitled to international protections under international humanitarian law. And the reason why that I mentioned that is because this huge camp that's growing and growing and growing is really at the whims of the Bangladeshi government. They can at any point in time fail to continue to keep it up or shut it down. They've threatened to send these refugees back to Myanmar, but Myanmar says, no, that you can't come here because you're not ours. So it's a really precarious situation, and it's growing really, really rapidly. And so as a result, there's been severe crowding, inadequate infrastructure, poor water and sanitation, and overall a lack of adequate healthcare. This picture demonstrates where the camps are built. They're built on these really, really steep landslide prone areas. So it probably doesn't come as a surprise that when a host government says, yes, come here, we'll accept you as refugees, we'll build a refugee camp for you. It's not on prime real estate, right? It's on lands that no one really wants. It's on lands that aren't fertile, prone to flooding, prone to landslides, and so on. And in this camp, diarrhea disease is the #1 cause of morbidity and mortality of kids under the age of 5, which is also the #1 cause of mortality in kids across the globe. And why this is important for a lot, I mean, it's obviously important for a lot of reasons, but one of the reasons is because diarrhea risk within the camp is significantly greater than diarrhea risk outside of the camp. And we care about that because, or that's an important tidbit to know, is because there's something going on there. Like, why are kids within the camp more prone to diarrhea than kids outside of the camp? What are the levels of protections that these kids are or are not getting? And why is this disparity happening? This is also combined with the fact that Bangladesh is placed on the Bay of Bengal, which is highly prone to these cyclone events that are increasing with climate change. So this map just displays the risk of climate change or of cyclones in the Cox's Bazar region. I probably should have mentioned, when I say Cox's Bazar refugee camp, it's really a conglomerate of refugee camps. I think that there's something like 35 that are actually active within the region. And so here's the biggest camp here, but then there's also a number of different camps located throughout the Cox's Bazar region. But no matter where the camp is located, they're all at really high risk of cyclone damage. The camps are also really prone to congestion. 93% of the population lives below the standard. This is a typo. It should be 3.5 square meters per person. 45 square meters would be like ginormous. 3.5 square meters per person. So that's being violated in the vast majority of the population. The population in Cox's Bazar is also really, really prone to flooding. Like I said, not prime real estate. And you can see all the blue here is the areas that experience flooding on a regular basis. The population is highly reliant on water that is provided to them. And primarily that's through hand pumps. There's about 100 residents per pump, which is a lot. So the hand pumps are like the ones that you think about that you like, yeah, pump with your hand. And the water quality is okay, but it's not great. 72% has no E. coli, which means that there's a pretty good proportion that does have E. coli. And that may or may not be due to the fact that 50% of them are in flood-prone areas. So the red overlaid here shows the areas where the hand pumps are in a floodplain. There is some sort of a network of piped water in the camp, but it's not great. It supplies, you know, technically a good portion of the camp, and it's better than the hand pumps in terms of water quality. So 92% don't have E. coli, but people mix these water sources all the time, even though there have been outreach efforts to not mix them. And so when you mix hand pump with piped water, the water quality goes down. You may or may not be exposed to some sort of bacteria in the water. And so there have been a lot of public health initiatives to use things like aqua tabs to clean up the water, but they by and large don't work. People think that they have a funny taste. They think they have a funny smell, even though they're tasteless, they are odorless, but they are not being used by and large. In terms of latrines, there's a good distribution of toilets within the camp. 35 people per latrine, that's kind of a lot, right? Not necessarily a problem in and of itself until, again, you start to think of things like flood-prone areas. 25% are in these flood-prone areas, which make these latrines at a huge risk of overflow and contamination. So our study is attempting to understand the role of the natural environment on diarrhea in this camp. And we're doing that through two different primary aims. The first is trying to evaluate whether there's a difference in the incidence of diarrhea disease before and after a cyclone event. And then the second aim tries to take that a step further by looking at whether or not tree forest cover loss around the camp modifies that association. The way we're trying to do it is by using publicly available data. And the reason we're trying to use publicly available data is because of all the challenges that I laid out before. And so what we're using are these epidemiological highlights from the WHO. And they are literally these PDF'd PowerPoints. They're like the most frustrating thing in the world. And I'm working on getting them to just like email me a spreadsheet, but we're working on that. And so what our amazing research assistants have been doing, have been painstakingly going through these PDF PowerPoints that look like this when you actually get to them, and pulling out acute watery diarrhea, bloody diarrhea, and other diarrhea. So record keeping has been like, okay, it hasn't been great, but there is data from the functioning health clinics within the camp. And so we've been pulling out these different types of diarrhea. And we've been pulling out the different types, or the different cyclones that have happened since 2017 when the camp became a thing. But what ended up happening is we're having a hard time kind of making our data meet up. And by that, I mean that we only really have data beginning in 2019. So again, we're missing that 2-year gap between 2017 and 2019. But between 2019 and 2021, we've had 4 cyclones being registered in the area. And we have variables on cyclones, on diarrhea incidents, morbidity, the population of the camp, health clinics, and recently, thanks to Jillian, we have tree forest cover loss. We kind of have some household indicators. And the reason why I say we kind of have household indicators is because they are collected pretty infrequently and they're often yes or no questions. So we haven't really established the utility of those. But I'm not writing them off yet because they have certain indicators like how often do you use aqua tabs? How often do you wash your hands? Where do you get your water from? Have you had diarrhea in the past 6 weeks? So we're hoping to figure out a way to include those in a bit of a more useful way. And then the variables we really, really want are the 2017 and the 2018 data, precipitation data. We have this data on cyclones, but as you'll see, it hasn't been overly useful. And so we're hoping to get precipitation data as well. And we want data on temperature. And I also want your guys' advice on what other data we need to answer this research question. And this is kind of what we've seen so far. If you look at, so the light blue here represents the rainy season, and then the dark blue is the peak rainy season. And that is the solid line indicates the trend line, which is a time series analysis looking at cyclones and diarrhea disease. And then the dotted line are the confidence intervals. So you can see that there's a little bit of seasonality there. And then the red asterisks are when a cyclone hits. So if you're like me and you're a visual learner, you're looking at this and you're like, I see nothing, right? You guys see anything? I don't really see anything. We're seeing cyclones happen and then we're seeing a decrease in diarrhea. We're seeing cyclone happen and an increase in diarrhea. And N of 4, like, I don't know that we can really do anything with that at this point. But I tried to do something with it anyways. I created these distributed lag models, which are basically models that allow us to see what happens 1, 2, 3, 4, 5 weeks after an event. So say a cyclone hits today, we don't expect to see a spike in diarrhea today, right? We expect to see a spike in diarrhea a little bit later down the line. When we look at the total cases of diarrhea, we see like maybe a trend, but not really. The line represents nothing significant, and then these ginormous confidence intervals. When we look specifically at acute watery diarrhea, we start to see a little bit more of a trend, whereas the risk of diarrhea increases 3 weeks post-cyclone. And then if we look at bloody diarrhea, we see kind of an opposing trend where your risk of bloody diarrhea spikes pretty quickly, but then drops off pretty quickly. Again, with a huge caveat that none of these are significant, our N is really small, ginormous confidence intervals. But it's interesting nonetheless, because it demonstrates that there might be a potential causative mechanism that's happening.
Did you order pizza? Nobody told
Ben
the name or
ordered pizza.
anything, so I'm so sorry.
No, you're good.
Just trying to figure out who ordered.
So the reason why this is has piqued my interest is because acute watery diarrhea and bloody diarrhea have different causative organisms, different mechanisms by which they operate. Acute watery diarrhea we can think of as cholera, for example. That requires high inoculum, so a lot of the bacteria or a lot of the organism. Bloody diarrhea is the opposite. It's a low inoculum disease. And so we're seeing these opposing trends that may or may not be important, but something worth exploring. And then I got news that there have been some cholera outbreaks. And so I thought this could potentially be interesting. So I added an arrow when there was a cholera outbreak. Nothing really important came up. You can see that there's like, I mean, it makes sense, right? Like we see a cholera case and we see an increase in diarrhea. That makes sense. We see a cholera case, increase in diarrhea. And if you force the model to give you a risk, it gives you like a pretty big risk of 4, but these ginormous confidence intervals again. So again, I'm not putting any weight in these results. They're just interesting to consider visually. And then just real quick, because we're short on time, the second part that we are starting to explore right now is investigating how tree forest cover loss impacts all of this. Obviously, with an influx of 1 million refugees, we're seeing a huge amount of deforestation happening. The pink represents areas that were deforested. Again, the crisis unfolded in 2017. So we're seeing between 2015 and 2020, a pretty massive amount of forest cover loss. And then when we look at that graphically, again, it makes sense. In 2017, this huge spike in tree forest cover loss. The reason why I have yet to run the analyses to compare or to like identify whether there's an association between tree cover and diarrhea and cyclones is because our tree forest cover data goes until 2020, but our cyclone and our diarrhea data basically doesn't even start until then. So we've got this mismatch. But again, I've been hounding the team over in Cox's Bazar at the WHO to be able to provide us with this data, and we're getting pretty close. So hopefully I'll be able to give you guys an update on that eventually. In terms of next steps, there's a lot of text on here, but it's basically get more data, figure out how to analyze the data, and to come up with some indicators for major events in the refugee camps, things like when certain areas got piped water, and so on. And with that, I hope I didn't go too much over my time. Thank you guys so much for, again, taking your lunch hour, and I'm interested to hear any questions that you have.